Here we want to solve this rational equation. We have 6 over 5x plus 10 minus 1 over x minus 5 equals 4 over x squared minus 3x minus 10. Okay, so for this rational equation, okay, the issue is the denominators, right? I mean, you know what, fractions, we don't like fractions, so how are we going to deal with the denominators here? Okay, so we're going to use something called the LCD method. Okay, what the LCD method says is, once we find the LCD, okay, for all of these fractions, we're just going to multiply, right? We're going to multiply each fraction by the LCD. Okay, so that, I mean, obviously that's what we want to do first, right? We want to find the LCD. Okay, so that's going to require us to factor everything as much as we can. So we get 5 times x plus 2 from the first fraction. And the second fraction is fine, right? That's just x minus 5. And here, when we factor, we get x minus 5, x plus 2. Alright, so what is our LCD going to be then? Okay, so we have a 5, right? You notice there's no 5s here, but we still need a 5 in the LCD. So the LCD will be 5 times the x plus 2 times x minus 5. Okay, so these are all the factors that are going to be in our LCD. Okay, what we're going to do is we're going to multiply each term. Okay, we're going to multiply each term by the LCD. Alright, so we get 6 over the 5 times x plus 2. But we're going to multiply that, okay, by the LCD. So times 5 times x plus 2 times x minus 5. Okay. Then we're going to take our next term, which is minus 1 over x minus 5. And same thing, we're going to multiply this times the 5 times the x plus 2 times the x minus 5. Okay, and we reach the last term here, right? It's 4 over that x minus 5 times x plus 2. But we're going to multiply it by 5 times x plus 2 times x minus 5. Okay, so what's going to happen now? Right, what happens is all these denominators should cancel out. Okay, so let's look at the first term, right? Denominator is 5 times x plus 2, but what do you notice? There's a 5 and x plus 2 here, right? These guys are going to cancel out. Okay, now here we got to be careful, right? What is remaining? Okay, what's left is the 6 times x minus 5. When we look at the second term, okay, the x minus 5 is down here. It's going to cancel out with this x minus 5. Okay, so as usual, be careful with what's remaining. We're left with the 1 times the 5. That's not a 15, right? It's 1 times 5 times the x plus 2. And then let's look at the last guy. Okay, there's x minus 5 here. There's x plus 2 here. That's going to cancel out with both of those. Okay, so what does that mean then? What's left? Okay, it's 4 times 5. Okay, I'm just going to multiply that out. So 4 times 5 does give us 20. Alright, so let's rehash this, right? We've found the LCD. We've multiplied each term by the LCD, and by doing so, all the denominators have canceled out. And what's remaining is the stuff in the numerators, right? So we're just going to simplify this, and then we should be able to get our final answer here. Okay, so let's distribute. So we get 6x minus 30 minus 5x. You got to be careful with your signs, right? It's going to be a minus 10 is equal to 20. And then we should be able to solve this guy, right? 6x minus 5x is 1x. Negative 30 minus 10 gives us minus 40 is equal to 20. Alright, so from here it looks like there's really only one last step, right? When we add 40 to both sides. Okay, we're going to get our answer here for x, right? X is equal to 60. Okay, so this is our solution that we got. Now, as a rational equation, you do always want to check your answer. Okay, now when we say check your answer, we mean when you plug it in, are you going to get a 0 in the denominator? Right? Because we know that fractions cannot have 0 in the denominator. Okay, now remember, let's assume that we did all the work correctly, or we made no mistakes, and we got x is equal to 60. So when we plug it in, we notice we're not going to get a 0 here, we're not going to get a 0 down here, and we're not going to get a 0 down here either. Right? So we can rightfully conclude then that x equals 60 is going to be the solution to this equation.